know how to use some of the key system utilities on a Linux box. Let's move on to show you how you can add users as well as groups on your system. So we'll label this section User Group Management. We'll do so with shell and GUI tools. And the features are pretty self-explanatory. Ability to control users and groups. Now we've got two basic tools for managing users, and that is the user add utility. So primary tools include, we've got group tools as well, but the user tool can also be used to manipulate group membership. User add, used to add users and modify group membership during user creation, as well as system config users, which is a GUI-based tool. We'll begin by exploring user add, the shell-based tool. So our task is to create a user named student1 using user add. We should also ensure that user student1 has a home directory beneath the home structure, which by default the Red Hat user add implementation will take care of. Now in order for this to work, we need to SU into the system. So we need to switch users into the root context to be able to execute user add. Then when we execute which user add, because user add is not in a standard user's path, we see that it's located beneath user sbin. If you want to know the package membership of this particular file, execute rpm query file, or qf, followed by the full path to the file. And we see that user add belongs to Shadow Utilities. Shadow Utilities also provides the main database beneath etc known as Shadow, which contains usernames and their encrypted passwords. So with that said, if you execute user add with no options, it returns the options that you may use to create your users, such as a base directory, a comment, a home directory, a shell other than the default, which is bash, so on and so forth. Which may lead you, if you're curious, to a question, and that is, where do the defaults come from? Let's note, default user settings, and basic group settings for that matter, derive from etc login.defs. So before we go off creating the student1 user, we should explore that file, etc login.defs, as it'll heighten our understanding of the defaults that are used by the user add as well as GUI utilities. So we've just used the pager less to take a look at this file. It's loaded with comments explaining each of the options. Now when a user is created, their mail directory will be beneath var_spoo mail, indicated by the user's username. So if we create a user named student1, student1 will receive mail to a file named student1 beneath var_spoo mail. We also see password aging controls. The maximum number of days, now in Linux terminology, 99,999 is also equivalent to infinity. In other words, this is the default way of saying the password never expires. You should think about the system policy whenever you set up new users and whenever you modify existing users. You can change global settings for new users by modifying this login.defs file. A more sensible value would be perhaps 45, 90, 60, or 30 days. But nonetheless, the default is set to a very large value. We'll leave it for now. The minimum number of days a user should hold on to a password is set to 0, which again is not the securest of options, but is the default. The minimum length is set to 5, and the warning age is set to 7. So 7 days prior to expiration, the user will be warned that the password is set to expire. Minimum maximum values for automatic Uid selection. If you notice here, the Uid minimum is set to 500. That means the first user created will be indexed at user ID 500. In fact, if we navigate to a separate shell as a user Linux CBT, We can see our UID, and it doesn't find it in the path, but we can grep Linux CDT from etc password, which is the default user accounts database, and as you can see, the first non-system or non-privileged user created, Linux CDT, has the ID of 500, which means the next user created will have an ID of 501. In other words, login.defs controls where users are indexed in terms of UIDs, and the same applies to GIDs. An upper limit is set to 60,000, so you can create users from 500 to 60,000, or you can create 60,000 minus 500 users, or 59,500 users on the system. You can always increase the limit if you'd like, if for some reason you need to define more user accounts, for example on an extremely busy ISP Linux system. We can ignore commented items, such as cron entries. Create home is set to yes. When you use UserAdd, the shell tool, to create a user, the user's home directory will be automatically created. And by the way, when we executed ID earlier, or UID earlier, we prefixed it with a U as opposed to simply ID. When you type ID, which is another command you should know, it tells you the currently logged in users, UID, GID, and any groups the user belongs to. So, this user's directory will be created, and the permission mask that will be set on files created by the user is 077, which means 700 for files or for directories, making the directories very secure. And one last option is set in the event that there are empty groups. By default, userdel will get rid of those groups if there are no more members, so that we don't have groups wasting precious GIDs. So there's your default file that governs the user creation process. It's etc login.defs. So back to creating our user, and that is the student1 user. We'll do so using UserAdd, followed by the username, student1. If you have specific settings that you'd like to have take effect, such as a different shell or a different home directory, you can indicate them. For example, to indicate a different shell, a shell meaning other than bash, indicate -s followed by the path to the shell. Perhaps a different home directory, -d. Let's move forward with the creation of student1. We'll echo the exit status. Doesn't seem as if much has happened. And that now means if we tail the contents of etc password, we'll see this new user, student1. Which leads us to our next point. So we've created the user. We haven't logged in or set the password yet. The next task is to set a password for the user. So set password for user student1. It's very easy to do. Just use the password command followed by the name of the user ID, which is student1. This will prompt us to set a password for the user. The user will be unable to log in until a password has been set, especially when using methods like SSH, which require, by default, non-empty passwords. So we'll execute password student1, and we'll set a simple password of ABC123. Notice that the PAM module, which is responsible for checking and setting the password, has complained that the password is very weak because it's based on a dictionary word, or a word that can be derived from characters from the dictionary, but it set it anyway. So now the user's password has been set. Now this leads us to another point. The standard user account databases, so user or default user accounts DB in a Linux environment is a file known as etc password. In there you'll find users, their corresponding groups, their home directories, references or a reference to shadow, and other items. Let's take a look at those items. We're going to navigate to etc and execute less, or we'll just cat the contents of the password file. We'll focus in on student1 and take student1's entry and break it apart. So for student1, we see the following. Username, this is the name with which the user will use to log in. shadow reference indicated by the X, which means whenever a login program such as SSH or login, which is connected to the TTY, authenticates a user, it will consult the shadow file for resolution of the user's password. The UID, this is auto-assigned and is usually the same as the GID in a Red Hat framework, and it begins with 500 for the first non-system, non-privileged user, which also means IDs beneath or below 500 are for system and privileged users. The next field is the GID, which references the primary group membership of the user, although a user can belong to more than one group, certainly. The next field is a description field, also known as a geckos field. The next field is the home directory, and the final field is the path to the user's shell. So these are the fields that you'll find in the password file. Now, historically, Linux and Unix systems have stored password information in the second field of the password file. But etc password, and we should just note this, is a world-readable file. And by that we mean anyone who has access to the system can read the contents of etc password. So as a consequence, over the years, over evolution of Linux and Unix, passwords have been moved from etc password to etc shadow. So note, etc shadow now stores passwords in encrypted form. Also, etc shadow is not world readable. It's readable only by the root user and the processes which have access to authenticate users, primarily the PAM or pluggable authentication modules. So with that said, we need to take a look at, to get the full story of any particular user, such as student 1, the etc shadow file, because it also contains multiple fields. So let's cat the contents of shadow. We will find one entry per user found in the etc password file, and we'll extract student 1's entry. We could have done the same for Linux CBT, and then paste it. So fields in etc shadow, for example, includes username followed by, and it's usually MD5, but we won't list MD5 because it could be SHA or some other algorithm. So we'll just indicate encrypted password. So the ABC123 that we typed in earlier is represented by these characters, $ all the way through the terminating 0, and the delimiter here is colon, which you could use awk to parse real simply, followed by the days since the Unix epoch the password was last changed. So days since epoch password was changed. And since we're going to run out of space here, let's place each of these fields on a distinct line. So we've got the first field being username, second being encrypted password, third being the days since the Unix epoch the password was changed. The Unix epoch was 01/01/1970. So 13,891 days have passed since the Unix epoch, since the user's password has yet to be changed. Or was changed, that is, since we just changed it to ABC123. So it was changed 13,891 days after 1970. The fourth field, which currently has a 0 in it, the days before password may be changed. So days before password may be changed, which in a secure environment should be at least 3 to force a user to hang on to a password before having the option to change it. And that's represented by a 0 here, which means the user can change his password multiple times in any given day without being penalized. The next field, which has the 99,999, represents the days after which the password must be changed. In other words, this is a value that's typically 30, 45, 60, or 90 days in most corporate environments. This is the total number of days the user may hang on to a password, which should be reduced. And the effective way to do so is via etclogin.defs. In the security section, when we increase the security or improve the security posture of this box, we will reduce and increase, or lower and increase some of the numbers depending on the field, of course. Now in the next field we have 7, and we mentioned that this represents the days before the password is going to expire, that the user is to be warned. So 7 days before 99,999 days, the user will be warned that the password will be expired. The next field, which is currently blank, and that represents the spot here, represents the days after password expires that the account is disabled. So days after password expires, that account is disabled. So you may want to offer a grace period to your users, after which point the account is definitely locked out. The next field, which is the second to last field, represents the days since the Unix epoch that the account has been disabled. So days since Unix epoch, which as mentioned is the 1st of January 1970, that the account is disabled. And you can disable an account using the user mod command. The final field is a reserved field, which means it's currently unused. So currently unused. So those are your 9 fields from the shadow file. When you combine these 9 fields with the fields from etc password, you then get the full database, or the full row or record for a user in a standard user accounts database on a Linux system. Ditto applies to most modern Unix systems such as Solaris. Now there are other utilities available to help us manage users, other shell-based utilities. Supposing we wanted to modify some of the properties of the current user. So let's set a second task. Modify user student1 to have password expire after 45 days. And that's where we'd use the user mod command. Let's take a look at user mod. We'll clear screen and execute user mod with no options, which returns the options that are available. You can even set an expiration date. You can change the home directory, set password inactive after expiration to inactive, force a user to have a primary group, or append any number of supplemental groups. You can lock the user's account using upper L or -- lock, which prevents the user from logging in. You may move the contents of the user's home directory to a new location, providing you use option lower D to indicate where the user's new directory will be, which will perform a move of the user's items in one step for you. You can change the user's shell. You can specify an encrypted password, which will function as the new user's password. You can map a user using SE Linux, so a user to the current Linux user, since they're separate entities. And you can even make the change that we're proposing manually via the shadow file. You can even use a tool like awk to make the change automatically to all users. So let's take a look at the shadow file. A nano of shadow, and you can set the expiration date, which would achieve a similar function. Let's navigate to student1 and just update 9999 to 45. Now this user will have to change their password by the 45th day. So in other words, 45 days after today. So that user's account has been updated manually the old-fashioned way. Now with that said, let's show you how to manipulate the groups on the system before we use the graphical tool to manipulate both users and groups. Primary utility is group add, but group add also includes group mod, which allows you to change membership information, and so does user mod, by the way. Using the uppercase G option, you can indicate supplementary groups. By by delimiting them by commas or using commas. So, how do you know or determine what groups are available in the system? Well, group add will add new group. However, the simple group command lists the groups on the system. And this is groups, plural, will list the groups on the system. So this lists groups on the system. But we're on the system. Well, again, we're in ETC. If we LSL group, you'll see there's a group file which contains the groups defined on the system and the associated members. So this information comes from ETC group. ETC group maintains group membership information by simply enumerating with a comma delimiter the members of the group. So, for example, we see groups that belong to users of the system. Linux CBT Student 1, this is the methodology employed by Red Hat for grouping users. But sometimes you want to create general purpose groups such as sales. So our task will be to create a sales group and add Linux CBT and Student 1 as members. Because through group memberships we can assign permissions to different folders or directories and or files throughout the file system. So to implement this task we'll use group add followed by the name of the group, sales. This creates the group and assigns a group ID into ETC group. Let's go ahead and give this a try. We'll echo the exit status and then we'll cat the contents of ETC group, where you see that we now have a new group, sales, with GID 502. Now we need to add members to this group. Now, just a brief note about the X that you see here in the group file. Groups support passwords, but most applications don't make use of this feature. So it's there to support perhaps legacy applications or applications that intend to make use of group passwords. So that's why you see an X between the group name and the group ID. It means that it references the gshadow file, and that's this file here, which currently does nothing, meaning none of the passwords are defined, indicated by the exclamation mark. So we now have this new group file. How do we add members? Very easy. You can either do group mod or user mod. User mod will allow you to modify one user or one user's membership. Group mod will allow you to modify various users. And if you man group mod, for example, you'll get more information about its usage. But group mod modifies to reflect the changes. It tells you. You can change the name, change the group ID of the item. It allows you to update the group. User mod allows you to influence the user's membership to the group. So use group mod to modify properties of a group. Use user mod to modify membership to the group. So we've added a group. Step 2. User mod, upper G, because it's a supplemental group. Unless you want sales to become a primary group, sales is the name of the group, followed by the UID. Linux CBT as an example. We'll make Linux CBT a supplemental member of the group. Let's echo the exit status, and we missed it there. Let's cat now the group file, and you'll see sales now has one member, Linux CBT. Now let's add the second member. And this will be for Student 1, allowing Student 1 to also take membership in this supplemental group. We'll now echo the exit status and then cat the group file again. Now we see delimited by a comma two users, Linux CBT and Student 1, who are members of sales, which means wherever we apply permissions for GID 502 or the sales group, the users Linux CBT and Student 1 will inherit those permissions. So use user mod to make those changes regarding group memberships. Now just note, two types of groups exist. Primary, supplemental. Primary is used by default for a user's permissions, especially when creating files and or directories. Supplemental, used to determine effective permissions. And any user can belong to n number of supplemental groups, but only one primary group. And for any user, if you type the ID command, you'll see this information. Let's just note another useful command: use ID to determine the group information of user. So here we've used ID for the root user. We see that the user's UID, GID are set to 0. The groups include what you see here. Now let's try for the Linux CBT user. This user's ID is 500, 500. Groups is set to 500 for Linux CBT. Now you may be wondering, why don't we see the new group information? Because that information is determined when the user creates a new shell. This whole session has to be reinitialized in order for the new group to show up. However, that's not a big deal to implement. So the effective permissions inherited as a result of modifying a group such as the sales group will not be realized until you create a new session. For example, SSHing into the system would do the trick. So in a separate shell, let's go ahead and SSH to localhost. This prompts us to accept the key for the user Linux CBT, and it will authenticate. Now that we're in, let's execute ID, and now you see with a new bash shell, we belong to the supplemental groups as follows. 502 for sales. So now in this shell, we can inherit permissions related to sales, wherever they're applied throughout our file system. We'll exit the session so that we can continue our studies since it's not as important. So let's just note that. Create a new shell session to realize new group membership information. Otherwise, it isn't read by default while the session's running, but prior to the creation of the session. So let's recap the utilities that are available. To create a user, use UserAdd, followed by the user's ID and optionally, or the user's name optionally, some settings like shell as well as home directory. Set a password using the password command. We know the meaning of the different fields in etc shadow that correspond to the different users. To add a group, use group add. To list groups, use groups. To modify a user's group membership, supplemental or primary, use user mod and either upper G or lower G to modify the primary group membership. So we've got user add, user mod, group mod. Those are your user and group management utilities. You've also got user del and group del. So user del as well as group del are used to delete users and groups respectively. Now with that said, what about the GUI? We can briefly or quickly go through the GUI. Since you know how the shell works, the GUI is very easy to follow. Launch an instance of systemconfig-users, and this brings up the GUI enable tool, which takes care of both users and groups. By default, the interface displays non-system, which means non-backgrounded accounts, as well as the non-root accounts. In other words, accounts beginning with the user ID 500, such as Linux CBT and Student 1. Useful information including the primary group, as well as, and you can sort by if you'd like these columns, as well as full name, which is the description field, login shell and home directory are returned. You can alter this output by navigating to the main menu and changing the settings of the environment so that you don't hide system users and groups, for example. So here are system users beginning with the UID root 0 down to the most recently created user ID of 501. And there's an NFS anonymous account of 65,534, which doesn't show up as well because the interface suppresses that account. You can interact with any of these accounts. If you don't want to see all these additional accounts, just navigate back to Preferences and say Hide System User Accounts. And there's some defaults in here, if you take a look, for UIDs, GIDs, as well as preferred private group is the same as UIDs. These are all defaults that are set when you create a new user. Let's modify the full name of student 1 by navigating to the full name field, which is really the Gecko's description field, and calling it student 1. If you wanted to change a shell, click on the drop box, and shells that are available are made available, including no login, which can be used for an FTP account. You can change the password. Account info, you can set it to expire. You can lock it. You can also change the settings from shadow. This is set to 45. Let's set it to 30. In fact, let's set it to 2. Days before warning 1. Days before change allowed 1. So we'll set this to 3, so it's a little more sensible. And here we see group membership. The primary group is always, in Red Hat Linux, the name of the user. However, you can assign the user to any number of supplemental groups, including sales, which you see is checked. Click on OK, and it updates the properties of the user's account and the underlying shadow file, as well as groups file, if necessary. To manage groups, just navigate to groups, and it's the same thing. To add or remove users from the sales group, just navigate to group users, find the users on the list, and remove the users accordingly. It's just point and click. To add a new user, this pops up a form. Just fill it in, and the user will be created with the next user ID. To create a new group, just click on Add Group, and it's that simple. So let's add a group for marketing. If you want, you can specify the GID manually. Otherwise, one will be provisioned for you based on the most recently used GID. To add members, double-click, go to Group Users, and find the members that are of interest. Now they're alphabetized, ascending, so we'll find student 1 towards the bottom. And now these 2 users belong to the group. It's that simple to manage groups. You can add them, add users, refresh if you're not seeing updates affected immediately, and interact with your users at any time. You can also search for users, such as student. This will return only accounts with student, for example. And you can make changes. The interface is very self-explanatory, very easy to use. So we'll quit this interface and move on, since you now know how to make use of the user add, group add, user mod, group mod, as well as the GUI-based tool.